Hi kids to another video on awesome maths today. This is Souvik here again and we will approach two problems in geometry today. Geometry questions, as you know, form the crux of most Olympiad papers and these two problems are no different. As always, I would request you to please like, subscribe and share my channel to as many of your friends as possible so that this content can reach out to other kids as well and be helpful to all of them. With that, we will now proceed to the two problems, and I hope it is as exciting for you to see the solutions to this as it is for me to solve these problems for you. Thank you. Okay, kids, so moving on to this problem, the first one, of course, in today's video, we have a circle with its center at O and a square has been formed connecting with the two diameters of this circle being the two diagonals of the square. So the question itself states in the figure AC and BD. So we have AC here and we have got BD here are the diameters of this circle. So obviously since they are passing through the center O, these will be the diameters. If the diameter of the circle is 91 centimeters, so basically each of AC and BD is 91 centimeters long. Find the area of the shaded region, right? And as some additional information, what we have been told is that we should take pi as 22 by 7 instead of 3.14. Now, how do we solve this problem, right? Now, there is a very simple way of solving this problem. See, in this circle, we will know very easily what is the area of this entire circle. Since this diameter has been given, we know that area of the circle is equal to pi into r square, right? So, area of circle is equal to pi into r square, where r is the radius, of course, right? And we know what will be the radius since the diameter length of the circle is actually given as 91 centimeters. Now, what do we have to do? We have to find the area of the square, or we can even find the area of these four triangles which actually make up this square. You might think that is quite difficult because there are four triangles, but no. All of them are exactly the same in size because, see, this is basically the radius, right? R. So OC will be one of the radii. OD is also a radii, R. AO is the radii, R. OB is also the radii. So since these two are the same and all these angles are right angles, this as the hypotenuse will also have the same length, right? So all these, so if we can find the area of one of these triangles, we just have to multiply that by 4. That will be the area of the square, and we just deduct the area of the square from the area of the circle to find the shaded area, right? So let us get on with it. Now the area of triangle, let's say AOB, right? The area of triangle AOB, what will that be equal to? That will be equal to half into the breadth into the height. So half into R, which is nothing but half into R squared, right? Now, what will be the area of these other triangles also? So area of triangle BOC is equal to the area of triangle COD is equal to the area of the triangle AOD, which is basically equal to this area of the triangle AOB, which we have already found as half R squared. Hence, the area of the square ABCD is equal to the sum of all these triangles, the sum of the areas of all these triangles. But since they have the same area as triangle AOB, we can write it as 4 into the area of the triangle AOB, which is 4 into half r squared, which is nothing but 2r squared. Simple. That is the area of this square ABCD. Thus, area of the shaded region is equal to the area of the circle, right, minus area of the square ABCD, which is pi r squared minus 2r squared is equal to r squared bracket pi minus 2. Right, kids? So the area of the shaded region becomes r squared into pi minus 2. Right? So now r is nothing but d by 2 and d is equal to the diameter 91. So 91 by 2, since it's squared, into 91 by 2 into pi. So what is pi, kids? Pi is nothing but 22 by 7. Now here we can do some rough work. So pi minus 2 is equal to 22 by 7 minus 2 is equal to 22 minus 14 by 7, right, is equal to 8 by 7. So into 8 by 7. Now kids, 2 and 2 we can cancel, right? So this will go into 8 2 times. 2 into 2 is 4. This goes into 8 2 times. Now 7 goes into 91 exactly 13 times, right? So the answer to this question is 91 into 13 into 2, which is 26. So we can do some more rough work here, right? 91 into 26, what will that be equal to? 6, 54, right? 2 and 9, 18, I'm sorry, 18. Yeah, so 6 and so the answer to this question is 2366 centimeter squared. So kids, in this problem we have learned two key things. First is that since you have the exact diameter given, you don't have to start replacing this exact length from the very first step itself. Imagine if you had started to input this length into all these numbers from your first step. What would have happened is it would have led to needless complication. You would have had to calculate r squared first step itself, right? You would have to again mention r squared here, the exact numerical figure. But since you did not put in the exact length, you could just do simple algebra, find out what is the area of the shaded region in terms of r square, and then we will put in the exact number for that r squared when it is really required. This saves us time and this also makes us put a lot less effort to find out the answer to this question. So kids, wasn't that awesome? Thank you. Okay kids, now we move on to our next problem for the day, which is also about geometry. And we have a rather complicated looking square here. So in this figure, a square ABCD, so a smaller square ABCD is embedded within a large square PQRS. There are also 4 rectangles, each with a perimeter of 36 centimeters and area of 56 centimeters. So these are the 4 rectangles which you can see, right? There are 4 rectangles here and all of them, each of them rather, has got the same perimeter and also the same area. So we have to find out the area of the square ABCD, right? Now, how should we solve this problem? First of all, we should spend some time understanding what will be the length and the breadth of each rectangle, right? So assume x as the length of each rectangle, right, and y to be the breadth, right? So in terms of the perimeter, right, so perimeter of a rectangle is equal to 2 into the length plus the breadth. So 2 into x plus y is equal to 36, right? Which means x plus y equals 18. Mark this as equation 1. Now we go to the area of each rectangle, which is equal to the length into the breadth. So x into y will be equal to 56, right? Now from the second equation, now as we know, these are essentially simultaneous equations. Now this gives us, right, y is equal to 56 by x. So substituting for y, right, substituting for y in 1, what do we get? We get x plus 56 by x is equal to 18, which means x squared plus 56 is equal to 18x. We bring the 18x this side to make it a quadratic equation. X squared minus 18x plus 56 is equal to 0, right kids? Now it is time to do some rough work to sort out our answer to this quadratic equation. So rough work, as I have explained before, you put the two x's this side and we have to find out some factors of 56 which will give us 18. Now 56 is 7 into 8, right kids? But 7 and 8, when we add them together, does it give 18? No. But 14 and 4, how about 14 and 4? So minus 14 minus 4, why will there be a minus? Because 18 is minus, so we have a minus 18. So we can write it as x squared minus 14x minus 4x plus 56 is equal to 0. Simplifying this becomes x minus 14 minus 4 x minus 14 is equal to 0, which means x minus 4 and x minus 14 is equal to 0. Now from this we can find that x is equal to either 4 or 14. Now when you substitute this here or here, right, so y, when x is 4, y will be 56 by 4, which is 14. The other way around is also true. If x is equal to 14, y will be 4. Now so basically the length and the breadth of the triangle are 14 centimeters and yeah, so x is equal to 4 or 14, which is the length of the side on these rectangles. Similarly, if x is equal to 4 or 14, y, which we know as 56 by x, y will be equal to 14 or 4, right? So these two numbers are similar. What does that mean? That length of each rectangle will be 14 and breadth will be 4. Okay. So now let's do some further labeling here so that we can find out the area of the square, right? Let us label this here as C dash, okay, and this part here as D dash, right? Now in rectangle, let's see the rectangle D C dash R D dash, right? So D C dash R D dash, we know that D C dash, right, this will be the length, so D C dash is equal to 14 centimeters, right? So x, one of these is the length, one is the breadth. So obviously the longer will be the length, which means DC dash will be 14 centimeters, right? Okay. Now, how much is CC dash? So CC dash is basically nothing but the breadth of a similar rectangle. All these rectangles are similar. So this rectangle, let's label this B dash. So rectangle B dash Q C dash C is the same as rectangle D dash R C dash. This is what the question itself tells us. So C dash is nothing but the breadth of each rectangle, which is nothing but 4 centimeters, right? Which is nothing but 4 centimeters. So what is DC or CD? So CD, which is basically the side of this square ABCD, is equal to DC dash minus CC dash, which is 14 minus 4, which is equal to 10 centimeters. Now we know the side of this square ABCD. Since we know the side, hence the area of square ABCD becomes side squared. So that's 10 squared, which is equal to 100 centimeter squared, which is the answer. So kids, from a seemingly complicated geometry problem which involved one small square and one larger square, several rectangles, wasn't it quite easy to find what is the side of the square and then consequently the area of the square as well? Isn't that awesome? Thank you.